welcome everyone. Kia ora. My name is Linda. I am a committee member. We wear these cool t-shirts. You can ask us any questions, particularly if there's anything you want to see here as well. Go that way. Yeah. Hi,
This is
camera.
how we're recording today.
We're recording via our laptop because our videographer is unfortunately sick, and in these days and times we want them to stay away. So I hope everyone checked in at the front. This is my health and safety announcement. Please check in with your COVID. Please use hand sanitizer everywhere. The bathrooms are just over there behind us. There's water also there. In case of an emergency, either get under the chair or we can exit and run out. I think that fire exit is actually best there, and we assemble uphill slightly.
Yeah, up and right.
Right, yeah, up and to the right. So that is the health and safety. I think that's about it with health and safety. We are going to have pizza coming at the end of this. Sweet, thanks. And tonight, first up, I know he's coming back. I'd like to introduce Blaise Saint Laurent. I don't know how to pronounce it. Cloud architect and security consultant from ZX Security, and he is going to talk about the common pitfalls in AWS implementations. Then following that, we will have Buzzy, who is sitting down quite comfortably there, principal engagement architect at AWS, who will talk about game day, and he will tell us what game day is for those of us who don't know as well. So cool. Blaise.
Hello.
Are you all ready? I'm trying to stall. Should I stall
All
more?
good. Hold on.
Right, all
Wait.
good.
Hopefully I don't have anything too offensive. Nope, good. Awesome. Slideshow? We're coming. Hey, that actually looks like it worked. Fantastic. Hi, everyone. Don't have a clicker, so I'm going to be coming back to my laptop a few times. So I'm here today to talk to you about some of the worst AWS security faux pas that I've seen in the last 2 years of being a cloud security person. Let's do this right now. Work? All right, here we go. So who am I? My name is Blaise. I've been in the security industry for 22 years, which is a very long time. I've seen a lot of things be trendy and not be so trendy. I'm now the architecture and cloud lead at ZX Security. What that basically means is I do a whole bunch of cloud security reviews and analysis. And the architecture is actually a separate line of business where basically I do a lot of design reviews because I've been around for a while. I came from a network security background. So for the last 10 years or so, I did primarily layer 1, 2, 3, 4, lots of Checkpoint, lots of Cisco, Juniper, Netgear, all the stuff that was popular at the time. Not Netgear, Juniper. I am cloud agnostic. However, I do work primarily in the mediums of AWS and Azure. And once for my sins, I had to touch an Oracle Cloud. I don't tend to trash products, but seriously, don't put out Oracle Cloud. You really, really don't want to. Right, my boss told me to put this in here. So ZX Security, we are a penetration testing company. Does everyone know what penetration testing is? Cool, sweet. Hackers for hire, we get paid to break your shit. We've got 25 staff. We've been around for 7 years as an organization, but our founder and a bunch of people that work at ZX have been around a lot longer. We were a Deloitte Fast 50. We're Crest certified, which means a lot if you are in the pen testing world. I can't actually see my own screen, so I'm going to take the privacy screen off my monitor. Now I can actually see my screen. What do? We do web-based security testing, internal and external pen testing, specialist work, security design, architecture reviews. We also have a vCISO offering, and thus ends the marketing part of our talk. So I do the cloud security reviews along with a team of 2 to 3 other people. Yeah, okay, thanks, Ian. Moving on. So, what are we here for today? AWS security, broad trends. So, obviously, being in Wellington, we look at a lot of government organizations. We have spotted some really interesting trends. Government and non-government organizations in Wellington tend to look at AWS when it's externally facing. So, when things have to scale really big or they expect a lot of external facing attention, it seems like our customers have been going to AWS when they want to do migrating of internal into a cloud. Azure is usually the one that we see. So what have we seen in the last 2 years? We've seen an evolution of how they're using the cloud. Thankfully, people have stopped trying to look at it as a VMware, but in the cloud, and just move all of their workloads kind of brainlessly. One of the great things that I saw was a large organization that I worked with who decided to go cloud, and they wanted to move dev and test first because, non-production is better. And so they got their traditional outsourcer to take an inventory of every server in their dev and test environment, and it was all bare metal. So they looked and said, oh, here's a 16-core, 48 gig server. Let's put that in the cloud. 16-core, 48 gigs. So they blew through a year's budget in a month. So these are some of the failed first attempts that I've seen. I've seen others where, unsuccessful migrations means that everyone in the company had access to the root and they didn't understand IAM, so they didn't bother with users. These kinds of things. Luckily, people are starting to understand that AWS is its own world. It's not just a VM platform, and it's got a whole bunch of its own security concerns. DevOps is driving a lot of that. DevOps, DevSecOps, Agile, whatever you want to call it. People think that they can move faster and get things done more efficiently using a new methodology. That's super. It's not always done right, and certainly there's a lot of ways you can shoot yourself in the foot, but everyone's excited about it, so cool. Hey, more business. The big thing is the basics aren't always necessarily done right. A lot of the compliance and audit frameworks that are starting to pop up around cloud security are still 5 years behind, at least. And S3 buckets are still what we get asked about the most when we say, hey, we do AWS security audits. They're like, oh, like S3, but there's a little bit more to it than that. But yeah, sure, we'll go with that. A lot of our customers are really nervous about serverless. They don't understand it. They don't understand how you can have code running, but not have a server running it. There's a certain legacy mindset in Wellington that everyone's trying to overcome, but unfortunately, people that have that legacy mindset tend to gravitate towards the top in management. So those discussions get kind of difficult, as much for the developers as security, unfortunately. So we have developers coming in and going, hey, let's do this serverless, let's use Lambdas and write directly to the database. And then the person that's asking for this cloud review goes, oh yeah, we've got a cloud. And they're like, okay, cool, well, how big is it? That's, oh, well, we don't have any EC2, so just kill that now, shall we? So it should be really easy. And then we log in and there's 300 Lambda functions. And we're like, oh, Jesus. Right. A little bit of a warning. My language can be sometimes a little bit blue. You can tell me which one's down. Right. So how do we assess security? We've done quite a few security reviews. AWS is by far the one that is easiest to automate, the low-hanging fruit. So we do both automated reconnaissance and controls assessment, and then we go in and we do a lot of manual testing, examinations. We actually get a fair number of interesting findings from non-cloud reviews. Because so many people are hosting in cloud, they'll tell us, well, we want to do a web app pen test, and then once we get some kind of access to the box, the first thing we do is we'll pivot onto the metadata server, and then all of a sudden, hey, it's Christmas. We'll talk about that example a little bit later. We also tend to look at any of the source code, especially Lambda functions are always tasty, because Lambda functions are run as a specific role. And people think that role definition is hard, so then those get really tasty. And then if you have any kind of internal access, or external facing access into a Lambda function, and the code is poor, lots can be done. So our little satellite appears again. So this is actually what I'm here to present today. So I pulled all of the reports that we had over the last 24 months that were AWS or AWS adjacent. We already use some normalized findings, and we try to categorize and tag all of our findings, because then we can try to get metrics like this. One thing that's really important to note here is there are some limitations to the methodology. I was looking primarily at how common a finding is, not necessarily how big of an impact it had on our customers' environments. Impacts and likelihoods vary wildly in the cloud context, depending on where they're applied. So the same finding can be a medium or a low in some cases, and a critical in others, as we'll see shortly. There are some findings that are artificially skewed because of two major reasons. One is they're super easy to pick up programmatically, so they'd be a great thing to put into your pipelines. You don't do it. And two, the default settings in AWS do not match our customers' requirements. Now, again, we do a lot of government work. The NZISM has some very strong views on certain aspects of computer security, especially password policies. And the AWS password policy does not meet NZISM requirements. So right off the bat, you'll see password policies way up here. That's primarily because more of our core corpus of data was government facing, so we had to write up the password policies. So here's the shiny first slide. So this is basically what we've found in the last 20 or so, 2023 reports. So a couple things to note really interestingly. There is a really, really disproportionate amount of findings that we find that have the potential to cause a major impact to our customers. And they're pretty much all in IAM. IAM is really hard. It doesn't get done very well. It doesn't get re-examined very often once the product is working. And as people add features to their apps, they tend to go, oh, it's not working. Let's just give new Amazon product.star to that running role, and then all of a sudden disaster happens. The other one that for us that's really important, we're really big on network visibility and application visibility monitoring and tooling. And a lot of people don't do the basics in AWS. A lot of people don't even know what the basics of monitoring AWS are. This is particularly true of a lot of the outsourcing cloud specialists that slap you a couple EC2s or some Lambda functions and then go, okay, cool, we're good. But the customer that they're dealing with has regulatory requirements, security impacts that they want to deal with, and they don't have the tools or they don't deploy the tools that are necessary. We'll talk about that a little bit more. Network access, I can tell you this is one finding. This is network ACLs and security groups just being mangled. We can talk about that a bit. Others, mostly service, I'll look into that. S3, you'll be surprised. There's actually not been any findings about S3 because Amazon has made huge, huge progresses in making S3 simpler to configure so that you don't shoot yourself in the foot. The 4 little checkboxes for public access, those are great. Use them. They are your friend. They will make your life so much easier. The biggest improvement I've seen that's affected our reports, because we're primarily a web-centric company, is the ability for CloudFront to go and access an S3 bucket using a managed identity instead of opening your S3 bucket to everyone so they can see it. Super, super feature. Use it. Encryption. The discussion around at-rest encryption is one that goes around the security community every year, and every year we all have a moan about it because it's required by literally every single security standard that people get audited on. ISO 27001, NZISM, SOC 2, they all say you must encrypt at rest. Fantastic. So AWS's SANS and all of their hardware level stuff, that's encrypted at rest. You're fine. No. You have to use operating system encryption at rest. So you need BitLocker or something. So this is a finding that happens a lot. My personal view is that, yes, absolutely, if you're spinning up some new resources, check that box because it costs you nothing and it gets you your compliance check. Retroactively trying to encrypt your EC2 hard drives, such a pain. It takes a long time, it has to get re-encoded, you're talking about downtime. It's not worth the pain unless you have a plan to do this. And honestly, most security budgets are really constrained. And I'd much rather see people addressing any of the other ones here than actually going and just spending 6 days re-encrypting drives. It's not a great value proposition. So I took all of the IAM findings that we had and I broke them out into a bunch of categories. Can people see that more or less? Right. So right off the bat, as I mentioned, the password policy, it's a big deal. In some cases, this is actually really bad because when they become high findings, they're, hey, look, someone set a root password to 6 characters and we cracked it by brute force. That's lame. That's not fun to find. And it's a hard conversation to have with our customers. The other one that irritates me a lot is this one right here, the use of root. Why are you using the root account? There's just no point. IAM is there for a reason. You can create any number of users. You can create them as full admins. We try to encourage our users to always use MFA. And for root, we try to get them to get hardware tokens like U2F tokens because that's really easy to lock up in a cupboard and then no one needs to know the password until you've got it on a paper next to it and you're sorted. MFA is a big theme, not being mandatory on AWS accounts. We've had a couple of people have the root account have API keys and certs that were active at the same time. And the problem with that was actually that the private key for that cert was on their source code repository. So that was poor because anyone that had access to the source code had access to the root account of their AWS server. Not ideal. And then there's a whole bunch of different nuances of IAM policies being used inappropriately or not at all that caused accounts to have massively excessive privileges. Now, I'm going to talk about that in a little bit, but by and large, that tells me one big thing, which is that no matter how many AWS managed policies they publish, people don't understand how easy it is to take those and build a functional least privilege policy and role for their users and their processes. And that's, I think, a big failing on the security industry, the cloud security industry in general. And I think that's something that everyone that works in cloud has to start looking at and working on a little bit better, because using those policies properly would just control the damage should anything get popped. And we'll talk about that in a second as well. Anything else exciting? This one here is really fun. We'll talk about that in a sec. That's the only critical in IAM, and that's because it was a complete compromise of the entire account. I'll talk about that in a second. Root, policy not actions. Yeah, that's pretty good. Cool.
What about permission standards?
Honestly, if I started seeing my customers using them actively, I'd probably have a finding about them. Most of the real world production accounts I've seen in the last year barely scratch the surface of writing their own IAMS policies. And so giving them all of the different frameworks like we saw last month is way asking too much. Now, there are tools that are potentially quite expensive that do a good job of those. And there's a whole cottage country of security products that have been implemented to do all this. But as a new developer or as a developer that's dropped into your standard small QE company, they're out of reach of a lot of the companies that I deal with. And it's really a shame because some of these tools have open source equivalents that either don't get maintained or don't quite keep up. And so they end up trying them, saying, no, it doesn't work, and then just doing it themselves. On that note, Netflix has some really, really good security tools for AWS. I recommend you go and check out their GitHub. It's got some really cool stuff, especially around figuring out what roles you actually need and then rewriting them. Kind of like what you can do right now with roles and policy inspection in AWS. The Netflix stuff predates that by about 2.5 years, and it's really quite useful. Any other questions? Sweet, let's go into a little bit more detail about IAM issues. As mentioned, password policy is mostly because of NZISM and audit being very prescriptive and the default's not matching. Lack of key rotation is one I did not talk about, and it comes up very often. CIS benchmarks, which is the kind of one of the more generic non-vendor-based security benchmarks, says that you should rotate your keys every 90 days. This is not immediately clear to a lot of people why this is important. A lot of users will say, well, only I have access to my laptop, and therefore I don't have to worry about rotating my keys because my keys are in this one file on my home directory. Sweet. Now, what about your CI/CD pipeline? How are those keys held? Who has access to those keys? If I go into your deployment engine and I go and look at the configuration files, am I going to see those keys there? And if that guy that set all that up gets fired, does he still have a copy? So it's one of the things, because it's a single factor of authentication. It might be super long. It might be locked down to your internal IP address by a SCP. That's great, but really it's just good hygiene to rotate them. There are tools that allow you to rotate your own keys and manage keys every 90 days automatically. AWS Vault, which I'll have the screenshot or the URL up there, is a really good one. It ties into your OS's Key Vault or Linux Keychain or TPM on Windows. Good tool. Get used to actually rotating your keys, because if any one of those keys gets popped, especially in CI/CD where you give your CI/CD pipelines crazy amounts of access, you're going to have a bad time. Policy configuration issues. There's two very similar sounding configuration options: pass role and assume role. Pass role allows a person that has pass role in their policy to pass on other access that they have within their policy to subordinate policies. So for example, if I'm setting up an EC2 instance and my role that I'm acting as has a pass role and then a bunch of other stuff, I can configure a new policy for that EC2 instance that has a subset of my roles. That can get really dangerous if my account gets popped. Or worse, if your EC2 instance has, because someone got lazy and went I'm.star in their policy, then all of a sudden they can start passing on all sorts of permissions to any other entity in AWS. Assume role, I mean, that's pretty obvious. You can potentially jump into other people or other subscriptions within your organization. Probably best to keep that one fairly tight. Not actions are the other ones that I see a lot of, which is great until you realize that people sometimes misuse them. So like, for example, what I've seen the other day was not action I'm.star, cool. But they didn't actually include not action STS.star, which is where assume role lives. So that role inadvertently still had access to assume roles of other roles in the organization. Not actions are generally just really not a great idea. I mean, about the only one that I like to see is a whole bunch of allows and then one at the bottom that says not action I'm.star to absolutely guarantee that they won't have access to the I'm access. General sloppiness, a lot of people use the wildcard matching and don't realize that, for example, you got get policy and then you got get policy and something else. If you get policy star, you get both the roles, not just the one. There are Python scripts to help you write policies that actually, even have graphical front ends. You go click, 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 click. Not a bad idea. And there's a lot of tools even built into AWS now to actually help you test your policies. And those are not used nearly often enough. Right, so I want to talk really quickly about server-side request forgery. Now, does anyone know what a server-side request forgery is? Okay, so for the other people in the audience, a server-side request forgery is when you, using an application on the server, are force that server to make a request on its own behalf, though you control the inputs and outputs. So for example, if there is a bug in a web app that allows me to make a request to another URL and have it return in the GUI, that's a server-side request forgery. Because when the request is made, the request will look as if it's coming from the authorized server. In this case, and why it's really important in AWS, is that there's this wonderful thing called the IMDS, the metadata server. And it's available to every single EC2 and container instance in AWS. And if you can SSRF it, you can request any and all data that that instance has access to. It's like popping root on the EC2 instance and then running the commands by hand using curl, except it's got a convenient web front end. In this particular case, we found server-side request forgery in a major security vendor's web front end, which was kind of embarrassing. And then we very, very quickly stopped once we realized that the role that the EC2 instances were running was highly privileged. At the very least, they had access to list every other S3 bucket, every other EC2 instance bucket, and I suspect create EC2 buckets. But because it was part of a job where we weren't directly contacted by that organization, we put our hands up and we said, guys, you got a problem. And we stepped away, even though that could have been potentially a really tasty bug. Funny enough, Capital One got popped in exactly the same way. Their web access firewall was misconfigured, and they were allowed to then go and download S3 buckets for all of Capital One, because a WAF is a highly privileged entity. And then a hacker whose name escapes me ended up collecting like 175 gigabytes of data. And she had mental health issues. The American justice system was surprisingly lenient and understanding, and I think she's only serving 10 years. She had actually popped 104 other organizations using this bug. So Capital One, look it up. It's a fun one. I wanted to talk slightly, even though it's not necessarily a critical bug issue, I want to talk about monitoring, because AWS does a great job of offering monitoring tools, which a lot of people think are too hard and therefore don't implement, which is really not cool. At the very, very, very most basic, your CloudTrail, your management CloudTrail across all regions, that should be the first thing you configure on any new instance. organization or subscription, because it just makes sense to track your administrators. That's kind of, maturity level 0. And then from there, there's a number of great tools. I really like Config. I know it's expensive. It used to be a lot more expensive when it was a per rule check cost, because you could run up a couple $100 on that real easy. But now they've changed the pricing. What Config does is it goes and looks at your resources, compares them to the checks of what you expect. No, that's wrong, because that's actually CloudWatch. Config gives you the information that you can then use to check with CloudWatch. But it's a great tool. I think Inspector does the same for EC2 instances, if I remember correctly. Yeah. And so you can put all of this into some common buckets, and then have CloudWatch giving you alerts and letting you know when things have gone wrong. This tooling is great. A lot of people just do not understand the value of this when you're getting hacked, to understand how they got in and what has been compromised. You can actually do a timeline of step by step. Oh God, this is how it's happened. The other thing that really bugs me, and I'm actually really glad more people are going serverless because this is poorly done, is actually sending your EC2 server logs into your monitoring tools built on CloudTrail and CloudWatch. AWS Amazon Linux allows for a really easy, more or less agentless install, so that all your syslogs and your Linux boxes get tossed directly into CloudTrail. You can do all of your logs, even for Windows or for whatever OS you find, installing the agent. It's a bit tied to SC.
Presumably logs to CloudWatch, not CloudTrail.
Yes, sorry. It gets put into an S3 bucket, and then CloudWatch can monitor it. Yes, sorry. I get those two confused a lot. Right, and then the other thing is the one that actually I think not enough people know about is your access logs for externally facing resources, specifically S3 buckets. I know it takes up a lot of storage, so you don't really have to retain them for very long, but it's super useful in an incident response scenario to be able to go and actually see what hit your S3 bucket, what resources it pulled. And especially if you don't know how they got access to that, becomes really handy. You can get access logs for load balancers, for S3, for CloudFront, and what's the other one? Anyway, short retention span, just so that your security blue team can actually use those resources. That's pretty cool. Yeah, and then everything else is just actually following the recommendations of AWS when it comes to monitoring, especially as you go into production. So, what are some of the doozies that we found? So I've already talked about the second one, the SSRF leads to metadata server in EC2. The top one is actually a bit of it's almost funny if it wasn't so sad. So a relatively small company was writing a crazy new web app they were super proud of, and it was a good web app. The actual web app developers knew what they were doing. We started talking about where it was hosted. They mentioned it was Amazon, but they said, don't worry, we've got an AWS guy. Which was fine. So we had the mandate to look at everything that was in the web app and any unauthenticated resources we could get. Cool, so the web app has a reference to an S3 bucket. We go have a bit of a poke in the S3 bucket, and we're like, oh, why can't I drop a file in there? That's bad. Hey, let's do a little ls, we can get the full listing. Hey, there's a zip file called sourcecode.zip. No, it gets worse, because it was actually a pull of their full source code repository, including all the credentials for the account that they used to deploy their website, which was, let's all hear it at once, root. Yeah, so that was a phone call that was not a lot of fun. Yeah, really super awkward. Lack of key rotation bit a couple of our clients because they'd gone and put all those API keys in GitHub to go and automatically deploy, but then their entire company had access to the same GitHub posts. So literally the receptionist could go and grab all of the ridiculously overprivileged entities that were going and doing all their pushes. This one was an interesting one I had not seen up until last week. So one of our customers wanted to do SNS publishing of emails really quickly, but SNS can get quite complicated when you want to allow certain externals. So they just said, okay, SNS, allow AWS.star. Oh, and by the way, the receivers was anyone that they wanted. So they could just use AWS as a spam relay. Super. Some of the lesser but important ones are administrator roles used and abused. So malicious user decided that they wanted to mine some crypto on the company dime, and because they had full admin, they went and disabled CloudTrail on one region. Yeah, that's right, CloudTrail. And then spun up a couple of EC2 instances for 7-8 days, helped themselves, quit, had a couple extra grand in the bank, got caught. I mean, it was really obvious, but it's one of those things where they should never have had that power. It always irks me when I see everyone and their dog having admin access when you could easily just either use an SCP or just configure roles for the products that you actually want to use. Because I know there's like 270 different services now in AWS, 230?
200, oh yeah, 270.
Yeah. Some of them are quite expensive if you spin them up. Like spinning up a GPU-enabled EC2 instance can run quite a lot of money. And if one of your developers decides that that's a great idea and you don't have the budget allocated for it, it can be a hell of a surprise and a really awkward HR talk. So what I recommend when people are asking me about how to set up their clouds is to actually figure out which products their production environment is going to use, and then create an administrator role that has those enabled, and then disable, well, by default, then everything else is disabled until someone actually makes a conscious effort. We'll talk about the whole concept of conscious effort in a second. No MFA, I mean, it's 2020, we shouldn't have this conversation, but we do. One thing I will point out to the nice fans of AWS here, Stephen, it's a really big limitation that we can only have one hardware token per account, and all of your competitors allow us to set up 2 or 3 hardware tokens. So at the office, for example, for our Azure instance, because we have all the clouds, we have 2 YubiKeys. One is kept at the boss's house, one is kept in the office for regular use. And then we also have an emergency access account that is locked up in our fire-resistant safe. Trust me, those little things melt.
If that bugs you, the only having one MFA thing, find your nearest AWS person and tell them to log a PFR, a product feature request, against it. Like what happens is the service teams, the IAM team, the more people that are yelling at them to implement a thing, the higher up priority it goes. And the more customers we've got complaining about the lack of multiple MFA devices, the sooner it's going to get fixed. So please come and yell at us, because that drives change.
Yeah, absolutely. We've been chasing it up as well on our side, and hopefully we'll see something moving. I would personally really like to see the password policy updated to something a little bit more modern, because the defaults are kind of shit. But that's just because I'm getting tired of writing the same finding over and over again, and just pointing out the fact that, I mean, the fact is, if you're a really mature organization, you're not using client passwords in any way. You're using some combination of API key or AWS Vault or Okta or some Whizbang. I mean, I personally use, and this is going to sound kind of scary, but I use SAML logins, and then I actually have all of my users defined elsewhere. And so it just drops in, I get dropped in, I assume my role to whatever account I'm going into, job done. I never have to worry about IAM users because there are none in my account.
So who do you use as the identity provider then?
I'm not allowed to say.
What if the identity provider has an outage, then you can't get into AWS as well, so you get a cascading set of failures?
Yep, but that's fine, because by that point, I have a number of different ways of, if it's production and urgent, then I've got that YubiKey that I can go to. If it's non-production, then we have a whole bunch of legal recourses and contractual resources to reclaim any lost productivity. And this is the thing, right, is that at some point, the cost of maintaining your user database becomes non-negligible, right? And we're a company of 25, we use 6 different cloud services. And because we're good security, people, we also change all the passwords on our Wi-Fi whenever someone quits, and we shut down all of their accounts externally and internally. That takes about 4 hours each time someone leaves or changes role or something happens. Now multiply that out by a company of, to a company of 250, and that starts to be, a pretty significant number. Now, luckily, we've only lost 4 staff in the last 5 years. So I would be pushing much harder to clean all this up more if we didn't have the retention rates that we do, but that's a nice problem to have. Past role use, just generally speaking, I'm.star is not a great idea in your policies. This is the other one that really annoyed me, is someone was paying a lot of money for Inspector, and Inspector was hollering and screaming, no, 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 I haven't been patched in 350 days on all their EC2 instances. And the last time someone had looked at Inspector was 6 months ago. I'm like, if you're gonna pay all that money, why are you not actually actioning it? The interesting corollary to this one was, this was a customer who had contracted someone to run a Kubernetes cluster for them. And instead of, sorry, a Docker cluster. This was a Docker swarm, not Kubernetes, because this wouldn't have happened in Kubernetes. And so they spun up 3 EC2 instances, put Docker on top, and then they told the customer, yeah, you're secure, because every time we push a new container to the Docker swarm, it goes and pulls all the latest patches and updates, so you don't have to worry. Great! Who's patching the Docker servers? 32 months without a patch, including the Docker escape bug that allowed people to go from the container to the host OS. Yeah, that was in the government. This is your data at work here, folks. And then my bugbear, logging. If you're going to set it up, please do something with it. It's great to have it in case there's a problem, but it's even better to action it before it becomes a problem. And I know that everyone hears this from all the security guys. I get it. Right, AWS security services. There are a ton of them. I went to this page this morning and there's 22 different services listed as security centric. Some of them are compliance, some of them are services you'd be using anyway, but they fall into that rubric. And it's hard if you're new to the AWS ecosystem to understand what goes where. I've already made the mistake of screwing up the names about 4 times in this talk, and I do this stuff for a living. It also doesn't help that every vendor has to have a trademarkable name for their offering, and therefore there is a real problem with actually understanding what the hell they're selling. There is a great matrix, I can share it afterwards. I didn't put it in here, that actually has a comparison of on-prem to all the different clouds. Right, things you really need to be studying and understanding if you're going to be effective at security in AWS, IAM, in-cloud logging, be it CloudTrail, CloudWatch config, Inspector, GuardDuty, they all have the same kind of general idea. Watch the stuff that you're running in cloud. We haven't talked about it, but AWS Shield and WAF. There's a lot of emphasis on DDoS right now in New Zealand. Important things to get right. And if you're a developer, please, please, please use KMS. Please put all of your secrets in places that the secrets are supposed to go. Right. Everyone likes free tools. So if you are an open source type person and you don't mind getting your hands a little dirty, these are some of my favorite tools. My 2 favorite tools right now are AWS Vault and Scout Suite. So AWS Vault manages your credentials. When you have 15 different subscriptions that you have access to on 6 different customers and you don't want to screw it up, great tool to have. Scout Suite is a compliance checker that goes through your AWS account and tells you all the things that are wrong. Now, those are only against the CIS benchmarks, but a lot of people are using CIS benchmarks, and it'll literally give you every reference to every CIS benchmark that you failed, which is quite nice. And Prowler does some more advanced stuff, but it's more prone to false positives. Cool. Most of you will know this, so I will pass it over for now. But the big things that I look for when I'm doing cloud security assessments are separation of accounts. So have one for your users, have a separate one for security, so logs and stuff, and then have separate accounts for every major production environment you have. Everything should be tracked. Everything should be logging. CloudWatch should be letting you know when things go wrong. And then for your users, obviously, MFA all the things. Use your management account for where you store your users. Don't let anyone else have a user outside of there, because then it defeats the entire purpose. And try not to use inline policies on each user, because it gets it really hard to actually understand what the downstream implications are. So groups are assigned to roles, and then they're assigned to assume roles into the environments that they're allowed to, and only those. And then MFA and external IDs are always a good idea for any and all role assumption. Yep, we've talked about that already. So basically, make sure your roles are default deny and least privilege. It's a lot easier to do that in dev than to give everyone full permissions in dev and test and then go, oh, we'll fix it in prod. That's how things end up with stars. And then make sure that any roles that are used to interact with AWS are tied down. And IMDS v2 is a really good idea if you can implement it, and you can implement it account-wide. And what that does is it actually makes authentication a requirement before you can go talk to the metadata server, which is actually a really good thing. Right, and then AWS provides a whole bunch of tools. Please use them because they're really good. Right, any questions?
So when you have these security findings,
Yep.
how many of those things can be attributed to not enough knowledge of the cloud, the cloud, and how much of it could be security in general?
My biggest bugbear right now, and this is a generalization based on my personal experience in the last 2 years, is that the brain is willing, the body is weak. So the customers have every intention of building a great environment. They go, we have an outsourcer. The outsourcer is really keen to make some money. And sometimes, if you don't define the requirements before you talk to your outsourcer, there's a mismatch of expectations. So it's really easy to stand up an EC2 instance and to sell that as a product, and that happens a lot. And then a lot of people in Wellington like to help their customers and make things better by customizing. And those customizations are rarely documented. And then, oh, we're getting rid of this outsourcer, we're moving to a new outsourcer, here are the keys to the castle. By the way, we have no idea what's in there. And that happens a lot in Wellington. There are security problems. The whole idea that you're putting your whole trust in a particular infrastructure is something that you have to understand. And to this day, the separation of responsibilities is really fuzzy in a lot of people's minds. So a lot of people assume that because it's an Amazon, it's secure because Amazon is patching. But that really depends on the service you're using and what Amazon has decided is their responsibility versus yours. When you add an outsourcer into that mix on top of it, it makes it all that much more fuzzy because then it's a question of, well, am I responsible for that? Is my third-party outsourcer responsible for that? Is it Amazon? And that's how big gaps get opened up. Like the Docker container example is my favorite one, where you've got a Docker swarm. Docker is not patched. All the containers in it are, and then all of a sudden, because Docker's not patched, you get full access to the environment. Does that answer your question? Cool. Anyone else? Sweet. Easy peasy. I have gone well over.
Thanks for that.
No worries.
Now we have, Blaze has brought all these
Oh, yeah.
stickers, they're quite cool stickers. We'll probably put them
In with the pizza.
and outside when we get the pizza at the end. So just have a look. Quite funky if you're allowed to put them on your laptops and everything.
They're mostly inoffensive. Mostly. This year's is COVID themed, so tread lightly. Cool. Thank you very much.
Like the
everyone.
back of your t-shirt kind of thing.
Oh no, this is that one was dirty because I was at ChristchurchCon yesterday. This one is that one there,
Cool.
which is slightly less offensive. Cool. Sweet.
Right, we've lost our next speaker.
It's just having a couple minutes there.
Yeah. Now, quick shout out. So last month we had security workshops. This month we're having talks. If people have a think about what else you want to have on these, what topics you want to cover or what workshops you'd like to do, please see myself or any one of the other committee members and just give us some ideas about what you want to see. And if you want to give a talk, really come and see me and we'll schedule you in, particularly for next year. Cool. I'd like to introduce the Principal Engagement Architect from AWS, Buzzy, who has been in AWS since basically I knew there was AWS, and that is many, many, many years ago.
Cool. Thanks, Linda. Hey, folks. So this is going to be a considerably more light-hearted talk around game day. Has anyone played the AWS game day? I've done it before. Yeah, I know you have. Yeah, it doesn't work for AWS already.
We don't all get to go to reInvent.
Yeah, so we run this outside reInvent as well, right? So
Right.
this is a thing we create And we run it every year at reInvent, and then we can run it outside reInvent as well for individual customers or groups of customers. So, if you see this presentation and you're interested in this being something that you want to run, either privately for your company or as a community group, we could run a game day, for example, for the user group. That's easy enough for us to do. So what is it? We give you a minimally working system to start with. We've got to give you some kind of start point. A team who've just met each other that day. So like you and you and you and you get to work together. Congratulations to our teams. Right? You might be all from the same company. Could be from completely different companies. Part of it is getting a bunch of people who don't normally work together to work together. Right? That also prevents people getting kind of hyper competitive about things, which is kind of nice. And then change. And that's kind of it. You've just got to keep that system running in the face of changes throughout the day. So, the way we do this is we have a fictional company called Unicorn Rentals. Unicorn Rentals is a bit of a disaster of a company, although it thinks it's absolutely amazing. And so we use this as a vehicle to introduce a bunch of concepts to you to make things kind of seem nice and familiar. And so we usually start with some kind of introductory presentation. We'll have the Chief Visionary Officer come and talk and tell you, welcome to Unicorn Rentals. Great, first day. The previous DevOps team, they quit on Friday. So we've decided to grab a new bunch of DevOps teams. That's you folks here. We've decided to implement a Shark Tank model of DevOps. So we're going to have a bunch of different people doing different DevOps things in kind of competition to each other. And hopefully the best one wins. Because we think that's a great way of implementing kind of fault tolerance and so on, right? So we have some kind of, discussion about this. Usually we'll talk about the key success drivers that make Unicorn Rentals the fantastic place it is. So, 13% of where we got to is luck. 6%, I want to have a guess.
Still?
6% is the product, that's what you folks are doing. 60%, it turns out, is leadership, that's me. And the remaining 33%, unsurprisingly, also leadership. So we have a nice, simple, fairly easy presentation here to talk to you about, lead you into the thing. We'll give you a technical overview. We'll talk about the solution that we've given you, the system that's running. Generally, it's fairly high level, so this is as advanced as it gets. Right? This is what you get to know. And then we dump you into a system as a team, usually about 4 people, that's running. Under the hood, the way this actually works is we're using a system called Event Engine. This is a system that my team have cooked up over the last few years. We have an administrative dashboard, which we get to control. We give you a team dashboard, which I'll show you later. So this gives you a bunch of information about what's going on. It allows us to communicate with you, to give you configuration, things that you need to do, instructions, hints, things like that. There's a scoreboard, so you can see how well you're doing or how poorly you're doing. It's amazing to me how many people get to the end of the day without ever really checking the scoreboard. They are so engrossed in what they're doing. We've actually run this internally at some, internal sales events where we've had rooms full of solution architects and technical account managers, things, all AWS staff. And we'll run an account or a team that does nothing. We'll just have a dead account there, set up with as it was in the morning. No one ever logs into it, just to see how it goes. Right, because the system in there will run for a period of time before things fall over and things go wrong and so on, but it'll accumulate points. And generally speaking, it's about 2/3 of the way down the scoreboard, right? Which means that about 1/3 of the teams are actively making things worse because they are getting so het up about stuff. And that's kind of the point of this, right? What you're trying to do is all of the stuff that Blaze talked about earlier, of configuration mishaps and things going wrong and stuff being in public S3 buckets, you name it. The stuff that would normally happen to a business in perhaps 2 years, we're trying to make that happen in slightly under 4 hours, right? So when things go wrong, it's really easy to get flustered to do the wrong thing. We then have an API that allows us to do communication back to the event engine, which controls and centralizes all this stuff. So we create this event, we run a game in the game day, and we have a team account. So you as a team, you get into this account, right? You federate in with a specific role. There are certain things you're allowed to do. There are certain things you're not allowed to do. We generally don't allow you to do things like buying reserved instances, renting a cloud HSM, other massively expensive, running X1 instances. We have people try, believe you me. But we try and restrict what you're allowed to do in there, right? The operators, that's us, it's the folks at the back end. We can always get in as an administrator role, so we can get in and do pretty much anything we'd like into the account, right? Which is, it turns out, as you'll see later, is kind of useful. But they're just normal AWS accounts. There's nothing special about these accounts, right? So under the hood, that's how it works. There's a team account for each team. So if we've got 20 teams of 4 people, there'll be 20 accounts there. And then we have a central account as well. So this is one account per event. You as the teams, you don't get access to this. You most of the time don't even know it exists. But we'll have some centralized infrastructure that goes in here. Maybe there'll be a bunch of web servers that are sending out messages, or a central S3 bucket or something like that that's in here. This can then communicate with the API, so it can update things like the scoreboard and the dashboard. It's all of my central code that I'm using to run the game that it runs. So that's the underlying structure of how we make things work, right? How do we build a game? So the game is all points-based, right? We have a leaderboard, we have a dashboard there that shows how the teams are doing, who's doing well, who's doing badly, what's going on. And so we've got to work out how to give points, right? So that's the fundamental kind of thing that we think about when we're running a game or designing a game. We award you points for good behavior. We take away points for bad behavior. There are points for cheating. Depending on how impressive the cheating is, those could be awards or taking things away. We've seen, and I'll talk to you later about some of the stuff that we've seen. There's been some absolute corkers of people coming up with really creative ways of cheating. But things like running stuff in different regions, trying to recreate the game day infrastructure, all the stuff that your team is running in your own AWS account so that you're shielded from what we're doing, things like that. We've had all kinds of cool stuff that people are trying to do. So we give you this dashboard, and this is kind of your ops view of what's going on, right? This is taken from the previous reInvent we ran a couple of years ago. So you can see we've got a bunch of teams here, and we've got the score. So you can see at the top 479,000 all the way down to 200,000 here. So quite a variety of scores depending on how people are doing. But there's also the trend. So you can see that the folks that are up the top here, they've got a trend of 12,000 on. They're doing pretty well. A lot of points here. This is like trailing average over a minute. So they're doing pretty well. But the team here, 397,000, they only got 7,000 points a minute. So they're going to get overtaken by these folks fairly soon. They've got a higher trend, right? So we try and give you some hints about what's going on. This isn't a workshop. So we don't generally have people at the front saying, then click this, then click that, then click that, right? What will happen is something will change. All of these will go red. It's up to you to work out what happened. Just the same as the real world, right? Something's fallen over. You don't get someone phoning you at 2 in the morning going, I followed step 15 of the instructions and it's down. You get someone phoning you up and it's down. You have no idea what's going on. Help. Yeah. Like who's been in that boat before? Who likes the idea of being able to do that in a controlled scenario rather than at 2 in the morning? Yeah, it's a lot more fun, right? So anyway, we give you, some kind of idea of what's going on. But it's not prescriptive, it's not detailed. Right? So yeah, you can see that the lucky 13 here, they're going to do pretty well. They'll continue bypassing these folks if they keep up that trend, right? All right, so thinking about the game, we have a bunch of different modules in a game. Each of these does a thing that then awards points. And broadly speaking, they fall into one of 2 buckets. Right? So the first is a message-based system. So we send you a message of some sort or a thing. You do something to that thing and you send the answer back, right? And so that's generally an ongoing thing. I might send you a message every minute. I might send you 10 messages every second. So long as I can get a response back from you, I can either add or remove points depending on whether the answer is correct, how long it takes, and all of that. The second kind of general bucket is this idea of completing a task. So we give you a task. Once you've done the task, you tell us the results, and we give you a whole load of points for that. Right, so we can then alter the relative amount of points depending on how hard these things are, and we can fork out, you can do one of these, and there's 2 of those at the same time, so bits of your different team can choose what they're working on, depending on who has what skills. But generally speaking, conceptually, they fall into these buckets. So let's talk about the message-based system first. So we've given you a system, right? Or you built a system that we've told you how to build, we've given you some source code, told you to deploy it, but we haven't told you whether to deploy it. Beanstalk or serverless or Lambda or an EC2 instance or whatever. Right? So once that's up, and we start sending you messages, right? You create a response and you send it back. We check your responses are valid and we give you points or take away. So we might send you a message. Typically these are fairly trivial things, like we'll send you a long random string, maybe 256 characters, And we just want you to do something to it, like reverse it, and then do a hash of it with a key that we've given you. And then send that back. So we know that you've got the thing, you've done the right transform on it, you've signed it somehow, so we know it's your team, you've sent it back, right? And then we can see like, how fast did you do that? Did you get the answer right? Did you sign it with the correct hash? Have you gone and stolen another team's hash? Right? We used to do printed out bits of card with team hashes on it. That was great when this was a brand new thing. What we got was people showing up who'd done this last year and just subtly wandering around with their phone, getting all the other team's hashes and then impersonating other teams with wrong answers to these points. Really, like, great. And super, super hard, as it turns out, for us to have detected up until they came up to us afterwards and said, "You never guess what we did." We're like, "Yeah, we knew what was going on. We didn't know who, but thanks, right, you're out." Yeah. All right. So anyway, so you know, we might also do something like we'll send you an image. We'll put an image in an S3 bucket, and we'll ask you to detect whether or not Linda is in that image, and tell us a yes or no answer. Right? If you get it right, you get a load of points. If you get it wrong, you get negative points. So you've got to train up a recognition model or something like that to do image detection. Right? And yeah, sure, you could implement it using PyImage or something like that yourself, but you know, probably easier to use a service or maybe some boilerplate code to try and make it work. So these kind of things happen, and then so long as that keeps running, you keep getting points. That's great, right? Typically with this, we'll have a story that surrounds it. So like everything we're sending you, message we're sending you is someone trying to order a unicorn. So like speed is important, we want you to get stuff back, right? We'll give you a minimal starting configuration. So maybe we give you an EC2 instance and it's running some custom code. You know, we receive the message, perform the transform, get the response. We describe the code quality as deliberate, which isn't to say that it's really bad, and it's definitely not to say it's really good. But we've been very deliberate about trying to ensure that the code works for some period of time for some value it works, right? Like it'll fall over eventually because there's memory leaks, or you know, it'll have some kind of version or some kind of counter that'll eventually go out of bounds and then the code will fall over or whatever, right? Pretty much nothing adheres to best practices. So there's a setup and it's running and it works at the start. So as soon as you sit down, you see your points totals going up and you get to feel really good as a team. But you know there's a big tidal wave about to come over you, so what it's going to look like yet. Yeah. All right. So when we do this, we have a bunch of underlying mechanics, right? So your team's been given a key. We've set everything up for you at the start. So we gave you a key so that you can use that to hash, sign the response or whatever. We know what your key is because we gave it to you, right? And the code that's running knows where to send the responses. So here is a shot of the dashboard. You know, you've got the score and the trend and what have you. And so we'll have input and output variables down here. So we'll tell you, like, here's the URL you should be sending messages to, whether it's an SQS queue or an HTTP endpoint or whatever, right? So, and that'll then be used like as an environment variable in your code. So you could go and update the environment variable with that value changed, right? But things are running, things where your code knows where it's sending stuff. If this changed later on, you could see that change in the dashboard. You can go change your code, right? Right. So this gives us a bunch of levers to play with. First is latency. So we might be asking you, like, you know, send us a new thing, send us a response every time we send you a message, and the quicker you can get an answer back, the more points you get. So we can constrain latency in a number of ways, right? Like we can have code that has built-in delays. So maybe the code we give you is a precompiled Go module, so that it's non-trivial to kind of reverse engineer it, right? If you don't have a reasonably decent software development engineer on your team, if you're mostly ops people, reverse engineering deliberately obfuscated compiled Go code is kind of hard. So great. You know, we can do other tricks like just excessively locking a database every time there's a request come in. Yeah. I mean, this is like stuff we do deliberately. And it turns out sometimes it's really hard to work out ways to be deliberately bad at things, right? And we want to be like deliberately, predictably bad at things as well, right? We might do excessive processing. So we might do a hash 1 million times over before sending the response. Right? And that's probably in the code, that's probably in Python, and you can just look, and there's a for loop that does like if, you know, for I equals 1 to 20 billion, run a MD5 hash and send the response. Here's for I equals 1 to 5, great, solved, right? So there's some really deliberate stuff in here. We might have like an external service that you've got to call out to get some further results that is also really slow, again, deliberately, so that you're not going to be able to respond to stuff super fast until you make some kind of changes, right? Couple that with scaling. So we can add additional load by throwing more requests at your system. What happens if you've got, like, let's say we started you with a T2 micro or a T3 micro, right? A small instance, not a lot of power. You know it takes a while to respond because you've got some latency here. What happens when we start putting more requests against that instance? Yeah.
Things are just gonna get slower.
Things are going to get slow. What about something like an auto-scaling group?
Yeah.
Stuff that scale out, right? And that'd totally be true if we'd set up an auto-scaling group. Right. And there is an auto-scaling group, but the DNS is just pointing to an EC2 instance over there, right? Yeah. Right. So we've deliberately set up a bunch of stuff. So you're sitting here and there's an auto-scaling group and there's scaling rules and everything, but it's not scaling. Why not? It's because all the traffic's going up there, right? Because some idiot set up the DNS wrong. Right. So we have a bunch of things like that we can play with. I'm giving you some tips here to some of the older games that you're less likely to actually see in the wild right now. I'm deliberately not telling you about some of the newer games that you're more likely to play with, slightly more devious ways of messing with your mind. Right, and so we managed to do that kind of stuff. Stability and reliability. We might have, a machine that crashes after a while. Blue screens, kernel panics, or whatever, because we deliberately tried to influence that. One of my favorite ones from a few years ago was when we got to having processed however many messages it was, the code would actually just run shutdown -H on the Linux instance. Just really frustrating because
that was super hard to debug.
It was a real bugger, yeah. From EC2's point of view, the instance is still up and running, so it passes all the reachability checks and so on. So in the console, it says the instance is running, but the OS is down. Like, that's super frustrating. Right, that takes a while to debug. And you can't SSH into it either because A, we lost the key, and B, it's down. Yeah. So, we do all of these kind of nasty things to you to try and do that. The other thing is requirements changes. So, hey, we were sending you a message and someone might stand up and say, hey, so we've been talking to the devs and they've decided that there's this thing called hashes. We like hashes. We've decided to implement hashes. So all the new messages will have hashes. And here's some new code in an S3 bucket somewhere that you've got to go with, right? And so the sooner you can implement that stuff, because the devs just dropped it in the S3 bucket last time, the sooner you implement that, the sooner you can get back to earning points. And then we can just flick a switch at the back end and start sending a new version of messages, right? And it's super interesting. You would think something like that's pretty simple, right? Like you've just got to copy a Python script to a running EC2 instance and update it, restart the web server. There's a massive variability in the whole dashboard goes red. And you'll see ping, one goes green, they've got another one. It's like popcorn, yeah. And the variation can be 2 minutes for the first team and half an hour upwards. We've seen teams literally sitting in the back of the room, still red and going down the leaderboard, and go over and see them, and you're like, what are you doing? They're like, oh, we've seen the new code and we're going to optimize it before we put it into production. Shit's on fire. You are losing shareholder value right now, yeah, and I mean, just like I said, some of the stuff that goes on in people's heads under pressure is quite amazing. All right, so task-based systems. So this is often we'll give you a bigger single thing to accomplish. If you want to bring the pizzas in, I can pause because I'm not competition for pizza. I know how this works. Yeah. All right, so we'll give you it might be that there's, we need to do a bunch of analysis to determine where we're going to expand into, right? We'll give you a starting point. Maybe that's a whole massive big data set sitting in S3, deliberately multiple terabytes of data, so you can't just copy it to your local machine, right? And then we'll ask you to perform some task, run an Athena query to tell us the second most popular country by origin to red unicorns or something like that. And then we test what you've done, right? So you provide us the answer and we can validate whether or not that's true and we can ask you other questions. Here we've got a lot fewer levers to play with, yeah. So we might change the data sets over time. So you need to give us a new answer half an hour later, otherwise we'll lose some points. We might change the parameters or the requirements that are going on here. But this is much more difficult for us to make those different events happen. But if we come back to some of the chaos stuff, this is really where the fun begins, right? So in addition to all of the things that are already going wrong because there's poor quality code in production or a plan change or whatever, now we've got a bunch of external threats and internal threats and general incompetence. Yeah. So we love talking about, say, we've got some bunch of pen testers. And they're going to be doing some penetration testing, but it's totally cool. It's not going to happen until 5 a.m. And then someone else comes up on stage 15 minutes later and says, look, it turns out the pen testers are based in New Zealand, so 5 a.m. is now. So I'm sure it'll be fine. Don't worry about it. But just if you see weird things happening on your network, that's probably the pen testers. Just, and yeah, pen testers sitting in the corner. Right, so we then have these chaos events. You familiar with this? Yeah, people who test in production. Like the testing in production is a scary enough idea for most people. For us, it's kind of table stakes. We don't test in production, we dev in production. Right? So we're releasing, for example, we might release a bunch of new code. And surprise, you get to have a bunch of new code. We always have access to your accounts, right? So we always have admin access in, we can get into the accounts, we can do pretty much whatever we like. We might ask you to do something like, hey, well, one of the task-based things is create a new CI/CD deployment pipeline. Like we'll give you some new code, create a deployment pipeline, use like code pipeline or whatever, here's some scaffolding to try and make it easy if you've never seen code pipeline before. And get that up and running, and then push this code through it. And as soon as it pops out the other end, that code will signal to us that it's been released, and then we can award you a ton of points. That's great, because I now control your CI/CD pipeline. So I can release some new code, and it'll go through your pipeline. And if you haven't implemented any checks, I can release breaking code, right? And so I can just all of a sudden, like, hey, someone, that team over there, they're doing really well. Let's just give them a faulty code release and see if they notice, right? And again, like this is what happens in real life. Developer develops something, they accidentally commit straight to master. PRs are for wimps. It runs an automated CI pipeline. You read a blog by someone, so you just did a fully automated, deploy into prod. What could possibly go wrong? And it turns out everything, right? In this scenario, because we deliberately don't have any guardrails, right? Okay. Let's talk about this. So we had one ages ago where we got one of our senior managers to show up, and he's a very, very confident guy, and he stands up at the front of the stage, hiding behind his laptop. He says, "G'day, it's Jeff here. I was an accountant until last week. I've just been promoted to network security manager." It's a South African guy, and he says, "I've been playing around with this tool. I think it'll be great. I don't think it'll cause any." Oh shit! And he closes his laptop and runs out of the door. Right? And at that point, we've made some changes to things, and again, everything kind of goes red. And so that person, what did we do under the hood? We went through and enumerated all your instances. We found the subnet that had the most running instances. We removed all the other NACLs and created a deny all NACL, and then stand back and watch. And so, like, we've already given you a hint that it's probably something to do with networking, because the guy who's just, sworn and run out of the door. And so, but these are the sorts of things we can do, right? Try and make it super, super hard. There's a bunch of other really nasty stuff that we've come up with in the intervening years that I'm not going to go into because it'll ruin the fun when you do eventually play a game day, if you know all of the tricks that we can perform. But that's an example of one that we've run for a number of years. And even having told you this, like, when this bites you in the bum, when you come play a game day, you will sit there and you'll spend half an hour trying to work out what the heck has gone on, and then you'll come and find me and throttle me when you finally work it out. Yeah. All right, so look, some lessons learned about this stuff. People are always cheating in new and exciting ways. So over the years, we've had to make this whole system a whole lot more resilient to people who are willfully cheating or not. I'll give you two examples. Way back when the dashboard that we showed you that had all the teams listed on it, right? You can click on a team and go in and see like a graph of the points for that team over time, right? Now, the first iteration of that dashboard, it actually embedded the team's name in the URL when you went into the detail, and the team's name was their AWS account ID. All right? Now, what we were doing was we were sending messages to the teams, and we set up a set of DNS entries that gave your account ID was an alias to your load balancer, right, where we were sending messages. So one of the teams got in and they altered their DNS to simply point to every other team in the room. Right? So most of the teams are working most of the time, and so long as most of the teams are working most of the time, it didn't matter what we did to this team because all the requests are going elsewhere. And again, we didn't work this out until they stormed the game and we could not beat them. We couldn't, we shut down everything in their account, we disabled everything, and they were still earning. And we were sitting here going, what the heck is going on? Like, it's like playing a game day yourself for real when you've got people beating you like that, right? So obviously, like that was 5 years ago. We've changed things since then. We've got a little smarter about how we do things. What else? One of the early versions of the game, we gave you a printed out manual that had a bunch of information in it. Most of the information was wrong, it was outdated, it was misspelled, it had coffee stains on it. We kept reusing them because the more raggedy and dog-eared they became, the more genuine it was. It was really good. People's notes from previous games, don't do this, actually do this. Turns out it's don't do it. And on the front, we'd have the usernames and passwords. So we had 5 users, they were all administrative users, they all had the same password, right? And so we gave that out to everyone. And it was the same username, same password for every team, right? And so again, one team, we were playing this at a summit event, 2 teams doing really, really well. They logged in, there were 4 people on the team, so they logged in as a user each, so they could see what each was doing. They changed their password, smart, right? They were at the top, and all of a sudden they just went red and everything stopped. And they came over and they said to us, so is there a point in the game where you guys just come in and delete everything out of our accounts? There were 5 users. There were only 4 of them, and they hadn't changed the 5th user's password. So someone else had found their account, logged in as the 5th user, and just deleted literally everything they could find in the account. And they ended up coming sort of like 4/5 of the way down the table. They had a lot of fun, and they were a little upset. But people are always cheating in these kind of weird ways that we can't expect. We've tried to put more guardrails around it now. We've tried to, I don't mind people cheating in some ways. If you're being malicious, particularly the teams that are already struggling down at the bottom, that's kind of nasty. But we've got a lot better at detecting that. We've got a lot better at remediating it. If you're down here and you've got someone who's trying to hit some of the teams up there, go for it. If they're getting smacked and they're already at the top of the leaderboard, it's more fun for them to try and deal with it. What else? Game-wide chaos events. So that example I had where the guy stood up at the front and talked about security and ran off stage, the problem with that was that it hit every single person in the room. And if you were on top of everything, great, happy days. If you were really struggling with what's an EC2 instance, not much fun if everything goes red. So what we've done now is a lot of the chaos events, a lot of the change events are points-based. So you hit a points threshold, we'll hit you with something. Right, you hit another one, we'll hit you, and so there's more and more speed bumps, right? And that way, the teams that are really struggling, they get to learn, they get to have fun, they get to see themselves progressing, but they're not getting the same level of just sheer beating that the really top teams get. Because we can get, order of magnitude difference in capability in a room, given some people who do or don't know AWS very, very well, right? The granular control of chaos events, this allows us to really go and hit those elite teams, right? It's great fun when you give someone, you do something like that deny knackle, that's great, and they find it out and they get to it. Then you do it again half an hour later, they don't catch it. What's going on? And they've completely forgotten what all the symptoms looked like half an hour ago. They have to start troubleshooting from scratch because everyone is, so stressed and so het up. I'm trying to make this sound fun, but that's always great in our arsenal to be able to attack people like that, twice, right? Adding cooperative aspects. This was really fun. We talked to some people after running a game day a few years ago, and they said, yeah, this is great, but it's quite masculine, it's quite competitive, there's a leaderboard and things. And so what we tried with some of the more recent games is to actually make teams reliant on each other. So I send you a message, and you don't just send it back, you've got to send it to another team in the room and get them to sign it. They send it back to you, you send it back to me. Right, which means now that you've got to run a bunch of services and you've got to rely on other teams in the room to use your services, and you've got to use other people's services like a big mesh. And actually, some of the teams that we've seen be most successful, we had someone at reInvent who showed up and got assigned to a team, and he wasn't technical at all. He completely rolled into the wrong session, but he was there, he was going to make a go of it. And he basically said, he got this concept of you have to share this stuff out. He said, right, give me write down what we need to do. And he just went around to all the other teams and sold himself and shopped himself oh, our services are awesome, they're super fast, they're really reliable, use us. And all the other teams were so busy and so hectic. Great, we'll use that. And they shot up the leaderboard, right, because of this cooperation within the teams. So we tried to make this less kind of male-centric, hyper-competitive, more about learning, more about cooperation, more about fun, while still retaining some kind of competitive aspect of trying to keep things up and going. As you move up from infrastructure services, it's really hard, right? It's super easy for me to add unplanned behavior to things like VPC and EC2 because they're unopinionated about the way the world should work. So I can create all kinds of weird scenarios using VPC and EC2 and things like that. Even things like Lambda and DynamoDB and so on, it's fairly easy to, it's fairly easy to put things like throttles in place and misconfiguring permissions and stuff like that. Some things like recognition or translate's really, really hard to try and, I won't say it's hard to misconfigure in a security sense, but it's very hard to try and add that sort of unplanned, unpredictable behavior to the stuff. That said, I don't know who's seen who remembers S3 going out in Virginia a few years ago? Service disruption, I think is their official term to it. There's a great video of an AWS trainer who's demoing S3 at the time. And he's trying to upload to S3. He's like, that's weird, it's not working. And 2 or 3 of the folks in the audience who clearly got just paged, they're like, dude, S3 is down. He's like, no. You're like, no, like it's down the whole region, it's out, like we don't have the leverage to try and just get service teams to take out whole services for us during a game day. That just doesn't work. All right, I'm at time. I hope it's been useful. I hope it's been like an interesting kind of discussion about some of the stuff that we do, how we do it. If you're keen on running a game day, so come and talk to Linda because it's the kind of thing we can run for the user group. It's typically they're about 4 hours, so half day. But yeah, certainly something that we can get together and run for you. Yeah, I'm around. There's a lot of other AWS folks around. Yeah, half the audience. And there's pizzas.
There is pizzas.
Cool.
They are outside, so please go and help yourself. And
Thanks, folks.
Sorry, is there? Yeah. Sure. Thanks, everyone. Pizza outside. You've heard, if you want to talk, come see me. If you want to know about a talk or you want to see a particular talk, come see me and I'll hassle an AWS person. If you want to be on our committee and help us organize this, please come and see me. Yes. Thanks, everyone.
Let's do a game day.
Let's do a game
Let's do
day.
2.
Oh, what are the secrets for this upcoming? You should have given us insider secrets for like